right. Welcome. I am Nicole Coleman from Stanford Libraries.
And I'm Claudia Engel. I'm at the Department of Anthropology at Stanford and also the libraries.
So this is our report on our experiences introducing a broad range of staff within academic libraries to AI through a series of conference workshops as well as smaller group sessions. And what we're suggesting with this is that training in practical applications of AI, particularly in applications that have social and cultural implications, require more than learning just the technology. And that's why our title, AI is not just a technology. What we're proposing is a more integrated teaching approach to machine learning that takes into account bringing in people with domain expertise who might not have technological expertise as well.
So there is really a significant overlap between the traditional information management that goes on in the library and the essential functions of classification and pattern matching that is done in AI. There's a quote from a report of the Library of Congress, the major US library, federal library, and they state that libraries have long been central to conversations about how to provide access to information at scale. Like catalogs, bibliographies, and subject guides, both for analog and for digital data, are all the outcome of a very long tradition of library expertise.
And in addition, libraries are deeply, deeply invested in the digitization of content and making that kind of content computationally accessible. So there's, with this degree of investment, libraries see it as very important to figure out how we're going to work with this material, both in terms of provisioning materials to others for work on, and also to use internally for our own purposes, for our own analysis and collection building and that sort of thing. So the examples here, we've got a few examples on the left of really large libraries that have digitized at least significant parts of their collection and made those available. And then on the right, examples of fully, completely digital libraries.
So while this digital format of text and image and audio and video is important in the library, the discovery is highly dependent on the organization, for example, by subject area and the field of study. And so we have library specialists across units that fulfill these very, very essential tasks, of course, of selection and acquisition and collection development, but also of providing a contextual understanding of the materials, both from, terms of provenance as well as in terms of descriptions. And so that really informs the selection and is very fundamental to machine learning processes.
And it seems that even within the machine learning community, this is becoming clear that contextual information and domain expertise is important. This is a quote from a very recently published paper by Zhou and Timnit Gebru, Lessons from the Archive, Strategies for Collecting Sociocultural Data in Machine Learning. And what they're saying here, as you can see, is machine learning researchers need to ask how much supervision and domain expertise and specialization is needed in collecting data for a given project. They suggest, a researcher working on training word embeddings on regional dialects might want to work with anthropologists or other domain experts. So this is becoming clear that this sort of expertise is needed. We are taking that as a given in our training.
So we have domain specialists, and they are responsible, among many things, defining the need of the project and identifying and preparing the data. And then we have the computing specialists, and they sort of translate that need, that request, into tasks, into programming, and then apply whatever appropriate methods. And then the very important step, of course, is evaluating the results, probably in an ongoing, iterative process, where both come together and look at this. So these AI projects, we think, require contributions by computing specialists as well as domain specialists. And so what we are thinking of is an integrated approach to knowledge building that considers the processes and roles involved in these projects.
And so what we identified as a knowledge building challenge then, faced with wanting to bring in domain experts kind of on an equal footing with computing specialists, is that many of those who are not going to be engaged directly in this kind of computational processes still need a functional understanding of the processes and the work involved. This is in order to foster good communication and really kind of efficiency in coordinating the activities. And then secondly, what we discovered is that, but available AI training tends to focus on the mechanics and in some cases, the theory of the technology itself. And so it's thereby catering primarily to an audience of technologists and programmers, and less to a notion of how is this applied and why, and building more intuitions that will help people who are domain experts be able to understand how it's relevant to their field.
So as we've begun working in this area, we have identified a number of learning goals. So we envision that the participants in these trainings and workshops are prepared to do a set of tasks. For example, or first of all, they should be able to outline the current landscape of relevant and state-of-the-art AI projects. Secondly, they should be able to articulate the problem to be addressed with AI and also the expectations from this process. Third, they should be describing the steps needed to prepare training data, to train, evaluate, and deploy a model, and also to use pre-trained models. Fifth, they should assess machine learning. Fourth is you should assess machine learning approaches and methods and tools with respect to relevance for particular projects, and should evaluate the outcomes. For example, what are the tasks and processes that can be modified, that can be improved, that can be scaled. Five, they should address the implications of data-driven models through critical consideration of the source of the data, the context, the bias, and the relevance to the question that's being answered. Six, they should evaluate the data sets with regard to their value for model training, for machine learning approach, which also again includes concerns of bias. Seven, they should analyze the shape of the data to see and to know where there might be gaps, where there might be anomalies or recognizable patterns. And eight, they should articulate how applications of AI, carry bias and state ethical applications in the organization and beyond the organization.
And to share an example of our kind of approach to kind of micro-training examples, this kind of focused sort of simulation. So this is something, an interesting kind of tool that allows people to actually go through the process just using their web camera of training a TensorFlow model. so this was made by Mike Bodge, Brian Moore, and Isaac Blanketsmith, and obviously something in response to coronavirus, ostensibly to train people not to touch their face. And then it shows the results of the training data built into the model. So when you're touching your face, you get this other response. So we found this to be really effective for students to build intuition, to really start to understand the significance of developing different classes of data, and then how you can use those in a kind of product like this to get a particular result. It's that kind of, this is that process of sort of watching it in real time, and helping them to sort of identify where things can go wrong as well with their training data, what works and what doesn't.
Another model we've begun to explore is how training and learning can be embedded in the actual projects by making use of notebooks. This is, Python notebooks is a very, very common tool being used by computer specialists in these projects, and for a number of reasons. There's a variety of very, very advantageous characteristics, and so we suggest to push this even further, to use this tool explicitly as a learning tool, and explicitly as a collaborative tool with going beyond the computer experts, with for example, the domain experts, because it affords, it is possible to quickly demonstrate the outcomes of some calculations, some models, to visualize, and to communicate in a larger group. So, exploratory programming, visualization, documentation, etc.
So that's it. We just wanted to end with this. We haven't come across this recent article in Communications of the ACM. Have you thought about talking about ethical implications of your research? Now, where we're coming from out of the library, out of the humanities and social sciences, talking about ethical implications of research is just, it's fundamental. It sort of, goes without saying. And I think that so speaks in some ways to the case that we are trying to make for a particular approach to teaching AI that really allows domain experts to be a part of the conversation, because we can't expect everyone in every field, and certainly not AI experts, to be able to understand ethical implications of all of the different applications. And yet, we know that within this conference, there's plenty of work being done, in issues of like criminal justice and healthcare and infrastructure, things that are going to have very important real-world impact. And so we're making a case that that this approach to training can really help foster communication between domain experts and computational experts.
Yeah, thank you for your attention. This is work in progress. We are continuously trying to think about how to change our training. We are continuously working with our colleagues how to make it better. If you have any comments and questions, please share them with us. We are very sorry we can't be in real time with the workshop. Thank you.